Hello students, welcome back to business statistics class. In yesterday's class we had studied one measurement of correlation, that is scatter diagram. Today we will study the next measurement for the degree of correlation, that is Karl Pearson's coefficient of correlation. So Karl Pearson's coefficient of correlation is also called as product moment coefficient of correlation. In calculation of problems, they can ask find product moment of coefficient of correlation, then it is understood they have asked to find out Karl Pearson's. So the Karl Pearson's coefficient of correlation is a measure of linear relationship between two variables. Now this is important, linear relationship. What is linear relationship is? That is, if you have two variables x and y, if there is certain change in x values, then definitely there is a certain change in y values, either it might increase or decrease. So there is some linear relationship between the two variables, and you're going to measure that with the help of Karl Pearson's coefficient of correlation. It indicates the degree of correlation between the two variables. So we are interested to know to what extent the two variables have the relationship. So for that we are going to use this method. So the coefficient of correlation between x and y is denoted by r to the suffix xy, or simply you can write it as small r. So this denotes coefficient of correlation. So x and y are two variables. For example, you can take height and weight. So the coefficient of correlation for two variables, height and weight, can be denoted as r. Here you can write at height and weight in short form, or you can just denote it by r. So we will see what is the formulas to calculate Karl Pearson's coefficient of correlation between two variables x and y. So r to the suffix xy equal to covariance of xy divided by square root of variance of x into variance of y. So you can write it in short form. So covariance of, instead of writing full word, you can write COV. So it is understood it is covariance of x comma y divided by, we know standard deviation is nothing but square root of variance. So here you can take square root for variance of x, so it will be standard deviation of x. So sigma x divided by sigma y. So r equal to covariance of xy divided by sigma x into sigma y. So you can substitute with the formulas. So the formula for covariance of two variables x and y is summation of x minus x bar into y minus y bar. So where x bar is summation x by n and y bar is summation y by n. So I'll explain how to calculate all these terms while solving problems. So now remember the formulas. So this is the formula for covariance of x comma y. It is summation x minus x bar into y minus y bar whole divided by n. Now the formula for variance of x is right square root. So variance of x is what? Summation x minus x bar whole square by n. So this we had studied in our third semester, third unit, wherein we had studied the concepts of standard deviation and variance. So in place of variance of y, substitute its formulas. It is summation y minus y bar whole square by n. If it is x, write x. If it is y, then write y, or if it is any other variable, calculate accordingly. So this is the formula for Karl Pearson's coefficient of variation. But for calculations you can use the simplified formulas. So in many cases, 90% of cases, we use this formula, which is very easy to calculate. So r is, that is coefficient of correlation, is n into summation xy minus summation of x into summation y divided by square root of n into summation x square minus summation x the whole square into n summation y square minus summation y whole square. There is another bracket, and this is for raw data. So this formula is derived from this formula. Simplifications is not a part of your syllabus, but it is very simple. They have first multiplied these two, that is in the form of a minus b to c minus d. First multiply these two, and then this, then these two, and then take summation to all the terms. Wherever it is a constant, you will multiply with n. So once you, this is not required, the simplification, but remember this formula. It is n into summation xy minus summation x into summation y whole divided by n into summation x square minus summation x whole square. And for variance of y, in place of that you have to write n into summation y square minus summation y the whole square. So this is formula for tabulated data, but you have problems based on only raw data, not for tabulated data. But just remember the formula. In place of small n, you will be having capital N, and here you have double summation. So because in tabulated data a frequency comes, so you have to multiply with f for all the terms. So it is double summation fxy minus summation fx into summation fy whole divided by capital N summation fx square minus summation fx whole square into n into summation fy square minus summation fy whole square. There is again another form bracket over here. So from the next class we will solve problems. I want you guys to remember this formula, and if you want you can use shortcut method also. For that, go through the third unit wherein we had solved, I guess, standard deviation with the help of shortcut method. Now we will see how to interpret coefficient of correlation. A positive value of r indicates positive correlation. That is, if r is greater than 0, we say that it is a positive correlation, and if r is less than 0, then we say that it is negative correlation. That is, if you get r in terms of negative value, we say that it is a negative correlation. If r is exactly plus 1, then it means perfect positive correlation, and if r is minus 1, then we say it is perfect negative correlation, and if r is 0 or very low, then we see that variables are non-correlated. So all these 5 points are very important to interpret each and every problem. You have to know these 5 points. That is, if r is greater than 0 or if r is any positive value, then we say there is a positive correlation. If r is less than 0 or it is negative, we say that there is negative correlation. If r is exactly plus 1 or minus 1, we say it is either perfect positive. If minus 1, we say it is perfect negative. If r is exactly equal to 0 or very low, then we say that the variables are non-correlated. Next we will see properties of coefficient of correlation. So the coefficient of correlation is independent of the units of measurement of the variables. So suppose you are measuring or you want to find out the relationship between height and weight, and you get certain value of r. There you have to not write any units like centimeters or kgs, because it is independent of the units of measurement. Remember this. That is just like the coefficient of variation. Even then we didn't write any units. So for coefficient of correlation, it is always independent of units. Next, coefficient of correlation is independent of the origin and scales of measurement of the variables. And this is the most important. Coefficient of correlation is a value between minus 1 and plus 1. That is, r always lies between minus 1 to plus 1, and it can take values as well as minus 1 and plus 1. Therefore, we can write minus 1 less than or equal to r less than or equal to plus 1. These properties are also important. It can be asked for either 5 marks or 2 marks. So from the next class we will solve problems based on Karl Pearson's coefficient. Thank you.